All right, so today we're talking about properties of similar polygons. So very close to what we talked about yesterday. This is just kind of a further explanation of it. So look, when I've got two shapes that are similar, you're going to be using a different sign this time. This right here, this almost looks like an approximation symbol, just one of them, means that they are similar. They're not exact, they're not about, they are similar. And remember, in order to be similar, they're going to have the same angle measurements, but their ratios of their sides are going to be also equal, just the ratios. What do I mean by that? Look, if these two triangles, triangle A, B, C, and D, E, F, are similar, then I know that A is congruent to angle D, B to E, C to F. Remember, you can match them up, first letter with first letter, second with second, third with third. Those angle measurements are going to be congruent. In other words, exactly the same angle measurement. The only difference here is the sides. Obviously, this one's bigger than this one, but if you take A to B, the distance from A to B, and you divide it by the distance from D to E, that comparison between the two should stay the same as comparing the other ones. Like this side, this bottom one, B to C, should be E to F, okay, that ratio. And lastly, C to A from F to D. Those should all remain the same. Let's take a look at an example. Now I'm going to change the shape on you, but we get the same idea. So are these similar? Well, right off the bat, the angle measurements, look, all four angles are 90 degrees. So it does meet this one, that all of them are congruent. The angles are congruent. Yes, that is true. Okay, so that checks. Now I got to check to see if the ratios are the same. So let's find out. Let's take this longest side, okay, which in this case is G to H or K to L, doesn't matter. And we're going to compare it to the longest side over here, N to M. So 7 over 10. All right, so if I wrote that as a decimal, it would be 0.7. All right, so I'm going to keep that to the side for a moment. Next one I'm going to check is I'm going to check the shorter side. Let's go from J to K, the top part. Well, that compares to N to P, the top part of the little one. And so this case is 3 over 6. If I do 3 over 6, 0.5. Uh-oh. So these are not the same. So if they're not the same ratio, then I know they are not similar. They have to be exactly the same ratio in order to be similar. So now we come to another example. Find the missing side if they're similar. If you already know that they're similar, we know that their corresponding angles are congruent, right? So A and W are the same, and we know that because we see a 1, 1. Here B and X are the same. They both have 2 little arcs. Y and C are the same, 3 arcs, and then Z and D are the same, 4 arcs. So right away, the angle part is good. So I know they all have congruent angles. The next is, if you're telling me it's similar, that means that their matching sides will have same ratios. So I look over here, A to D is 13, W to Z, they didn't give me a value. So I can't really use that. So I'm going to leave that alone for right now. But they did give me a value from over here. I can show you that, look, from D to C, I'll write it over here, D to C, which is, in this case, 10. And when I want to compare that to Z to Y, because it's the bottom, they match up, right? So I'm going to say that's 15. 10 over 15, if I do a little bit of math here, that reduces to 2/3, which as a decimal is approximately 0.67. Okay? Now what I want to do is I want to compare some of the other sides. Well, if I see there's a 24 here, but I have something missing. So the only thing I'm really trying to find out is this one here. So let's set that one up. I went from the smaller shape, so I'm going to go CB, and I'm going to compare that to YX. CB in this case is 12. YX is, I just don't know. That's the letter M. I know I need to make this 2/3. So at this point, you might be saying, well, how do I make this 2/3? Well, what number goes into 12 twice? So that'd be 6, right? So if I multiply that by 3, that should tell me that this bottom one has to be 18. 12 over 18, which reduces to 2/3, which is also 0.67. So 18 is what I'm looking for. Now, if I went by that too fast for you, what I can do is I can just base it off of just this part right here, right? If you're not comfortable figuring it out on your own, you can say, look, I know that 10/15 has to be equal to 12 over some number. Okay, and if you recall, you can use cross multiplication to figure this out. We can say that this is 10 times M is equal to 15 times 12. Okay, And so we crunch out those numbers. So 15 times 12 is 180. I divide both sides by 10, and I find that the m is 18, which is what I figured out already, but I just wanted to show you that's how you do that. All right, that's it for notes today. There'll be some extra examples in classwork.